It's 9 a.m. Let's start. My name is Pedro Lopes. I'm a program manager in the SQL engineering team. I have here with me Pam.
Hi, I'm Pam Lahoud. I'm also a program manager in the SQL Server engineering team.
And today we're dedicating our session to, as you see on the screen, real, tangible, practical guidance in terms of configurations and other known best practices to make sure your SQL Server roars, because we're the Tiger team, and therefore we roar. Take it away, Pam.
OK, thanks. All right, so good morning, everyone. Welcome to day 4. Thank you very much for making the really long trek out to our room.
Kudos to all of you.
Yes, I hope you brought caffeine. So this morning, we're going to start with practical guidance. And it's not the sexiest session you've seen here. We're not going to talk that much about 2019. We will talk a little bit about some of the new features that have come in SQL Server over the past few versions. But really what we want to give you is practical advice that you can apply today in your environments to make a real change right now. And if you're a seasoned DBA and you've been around the block with SQL Server for a while, a lot of this stuff might not be new to you. You might have heard it all. It's scattered around in all different kinds of blogs and articles and documentation and tweets and SQL help hashtag and all of that. So you may have seen it all, but what we wanted to do is bring it all together and organize it and give you kind of a roadmap for how to build or how to support a tier 1 SQL Server. So let's start with the obvious question. What is a tier 1 SQL Server? Well, what we consider a tier 1 SQL Server is anything where performance really counts. Availability really counts. This server has to be there and it has to be performing. It's running a mission critical workload. It has low latency requirements, all of these things. So typically it's running on high-end hardware, lots of cores, large amount of RAM, very fast, very expensive storage. It may or may not have very large databases. So terabytes and terabytes of data. We're even getting up into the petabyte range of databases. It may have heavy analytical processing. So you may be doing very large reporting queries over these very large databases and very large tables. It may have high transaction throughput. Hopefully those two are not together in the same system, because that makes it even more complicated. But high transaction throughput would be low latency, sub-millisecond queries, lots of updates, lots of inserts, very fast ingestion of data, things like session state or some kind of ticker or order processing or something where you get a really high throughput transactions. And those are generally smaller databases, but they can also be very large as well. And then the last piece would be very strict SLAs for high availability and disaster recovery. So near zero downtime, 5 nines of availability, no data loss, being able to bring that system back up very quickly. Okay, so this is typically what we consider a tier 1 workload. And we work with a lot of our tier 1 customers to help them be successful on SQL Server and to help solve any issues that may come up with the product or with their environments. So what we're presenting to you today is based on our learnings from dealing directly with customers through our support organization and through our own interactions with customers. What have we seen that's caused problems, and what can you do proactively to avoid those problems? Okay. All right. So where does performance, where do you spend your time to get the best performance out of the system? Well, it happens at every level of the system. It happens from the ground up. So the first thing is, of course, the hardware that you choose, the platform that you choose. Are you on physical hardware or virtual? Do you have a SAN or do you have direct attached storage? Things like that. So that's the baseline of the system. And then on top of that, you have your operating system. So we're going to talk about settings. We're going to focus mainly on Windows. We don't have a huge amount of learnings on Linux yet. Linux is very new with SQL Server, so we don't have a lot of practical guidance around Linux. There's a lot of information online, documentation, and things like that that you can review. But as far as what we've seen our customers doing, we haven't seen a lot of practical guidance there yet. So that'll probably come next year. We'll be able to talk a little bit more about practical Linux guidance. So we'll focus mainly on Windows. And then, of course, SQL Server. There's many different ways that you can configure SQL Server. There's all different settings in the engine itself. But then, of course, there's all these super secret trace flags, some documented, some undocumented, which we're trying to get away from anything super secret here, but there are still some trace flags out there. And tempdb, everyone's favorite topic. And then, of course, this clicker is slow. Okay. Last piece would be your application. So after all, SQL Server is a platform on which you run an application. So if you have the best hardware and the best operating system that's configured perfectly and has all the latest updates, and SQL Server is configured correctly and everything is good to go, and then your application is garbage, then you're still going to have bad performance. So there are things we need to consider in the application. Obviously, query performance, how do you monitor and analyze and tune queries? How do you maintain your databases to make sure that they continue to run well? These are what we are going to talk about today. And an issue in any one of these areas could spell a performance issue on the system as a whole. So it's important for you to be solid in each one of these tiers of performance in order to make sure that the system stays up and healthy. So that's going to kind of guide our talk today. So let's start with hardware. I don't work for a hardware company, I work for Microsoft. So I don't have a lot of advice here except to give you the few points that, that we've seen that kind of touch SQL Server. So the first thing we'll talk about is platform. Do you have to run SQL Server on a physical box? How many of you are running SQL Server on a virtual machine? There you go, like almost the whole thing. Is anybody only on physical only? I see. You? I think that's less than 10. Okay, so everybody's embraced virtual. So you don't have to be on a physical platform. Sometimes it's the easiest, and sometimes if you really need like crazy fast sub-millisecond latency, sometimes physical hardware is the easiest thing to do. But it doesn't have to be. You can run SQL Server anywhere you want. So physical is, of course, the first option, then virtual. What? I did two at the same time. So then virtual, VMware, Hyper-V, wherever you want to run it, virtual works as well. And you can, and there's, depending on how you configure your virtualization platform, you could have little to no latency from adding that virtualization layer. So it's just as good as physical hardware in our minds. Then there's infrastructure as a service. So run your VM in the cloud. This is nice because it means you don't have to manage the underlying hardware at all. You can just spin up a VM in the cloud. It's easy to scale, that sort of thing. And again, it can be just as performant as your on-prem machine. So we'll talk a little bit about infrastructure as a service, or IaaS. And then the last one is platform as a service. If you want to just throw out all the management altogether, you could just spin up an Azure SQL DB, and that works great too. But that's not really what we're talking about here, because there's not much for you to do except for application level tuning when you're on Azure DB, which is, both nice, but not what our session is about. So we're not going to talk about paths today, but I wanted to mention it because it is an option. And really, any workload you have on SQL Server should be able to be supported on any one of these platforms. They all scale to very large databases, really high throughput, and really fast performance. Any one of these platforms should work for you. It just depends on how much you want to manage yourself, and how much you want to spend, and how much flexibility you want. Okay, so any platform should work. So let's start with the physical server. And this know your workload, this is really important no matter which platform you're on. I talk about it in physical server because if you're buying hardware yourself, you really want to think about how much you need, and because you can't really make changes. If you're in a virtual server, you can kind of adjust on the fly as you get the thing in production. You realize, oh, I actually need a little bit more RAM. I didn't expect that. I can just, kind of add some more really easily. But when you're buying physical hardware, it's a little bit harder. You have to do some of that due diligence ahead of time. So it's important to know your workload because the kind of server that you're going to buy might vary depending on the application and the workload that's going to be running on that server. So we've got basically two patterns that we talk about with SQL Server: OLTP, which is your transactional processing, and OLAP, which is your analytical processing. So transactional processing would generally be short, fast transactions, single row operations, updates, inserts at a high frequency, high concurrency. So you're going to have a lot of little queries all running at the same time. And that's going to be a little bit of a different pattern than an analytical processing system, where you would have large queries, long-running queries, and those queries will probably go parallel. They'll probably be running across multiple threads. but they'll be very long running. They have a tendency to do a lot more I/O. They use a lot more memory just to execute the query versus those small OLTP queries that are usually short, small amount of memory. So those are two different workloads. So for OLTP, I would say the core speed itself, the speed of the individual core is important because those queries are going to be running on a single core. They're not usually going to go parallel. So you're not going to be able to speed them up by adding more cores. The cores themselves have to be fast. You do want to have a lot of cores because you want to have concurrency. You want to be able to run as many of those OLTP queries at the same time as you can. So you do need a large number of cores, but you do want to pay attention to the core speed as well. You do still want a large amount of memory, even though the individual queries are maybe not using a lot of memory. You want to make sure that the data can be in the buffer pool. You want the data to be in memory because you don't want to have to do I/O. Even really fast I/O takes time. So you want as much of that database to live in memory, or maybe even you want to leverage in-memory OLTP where it has to be in memory. So you do want to have enough memory to at least support what you think the size of the database may be. That's the way you're going to get the best performance. If it's a very large database, then you can't have it all memory resident, but you want to make sure at least the most active portion of it can be in memory. So enough memory to support that. And for these systems, I would say disk may not be as critical because if all your data is memory resident, I don't really care so much about your disk performance, at least not on the database file side. On the transaction log, I do, because of course I'm going to be writing to that transaction log as my transactions come in, and delays on the transaction log will be immediately felt in an OLTP system. So I want my transaction log write times to be fast. I don't maybe care so much about my other data disks. So for OLAP, again, a large amount of memory because these queries are going to be really big. And disk here is really important because generally we're going to do a lot more disk I/O because if we're on a very large database, it's not going to all fit in memory. So here we want to pay a little bit more attention to the speed of our disk system. And then as far as cores go, a lot of cores so that we can go parallel with the queries, but the individual core speed, not as important here. Disk considerations, so the type of storage I don't really care about. I'm not going to tell you you have to have a SAN or you have to have direct attached storage. I don't really care what kind of hardware you have here as long as it meets your requirements. So in order to meet your requirements, you have to know what your requirements are. So when you ask for storage, don't just say I'm going to have a 1 terabyte database, so give me, I don't know, like a 1.5 terabyte of disk. You can't say that. You need to know what kind of activity is going to happen against that disk. How many IOPS are you going to generate? How much throughput do you need? What are your tolerances for latency? These are the kinds of requirements that you should be asking of your storage subsystem. Not how big is the partition, but how many IOPS can I sustain? How much throughput am I going to get out of this thing? And how fast is it going to be? That's what you really need to know. So you need to have some idea of what kind of I/O patterns your application is going to generate. So it's going to involve some testing. As far as the actual hardware of storage, I would say nowadays, if you're on, and actually Argenis quoted me on this, he says, tell them if you're on magnetic disk, you're out of the game. He's like, you should really, no more spinning media, right? He's like, you should be on some kind of solid state flash storage, NVDIMMs, whatever, non-volatile media, that really the days of spinning media are kind of over.
You did make an exception. If you're in a ginormous SAN, but you have like a couple terabytes of SSD-based cache, then you should be fairly okay.
Yeah, he's
intelligent storage, but
right. He said if you're on one of those fancy SANs where it like balances the workload for you and has tiered storage and does all that fancy stuff, then you can have some spinning media in there. But for your tier 1 servers, you probably want to be on something faster. Okay. So before I move on, any questions on physical server?
At any point, in the context of what you're talking about, just raise your hand if you have a question, and
yeah, we're happy to answer.
We can entertain a couple of questions in the topic that we're talking about.
Okay. So virtual server. So again, I don't work for VMware. I do work for Microsoft, but I don't know that much about configuring Hyper-V. However, most of the recommendations are the same. Know your workload. Make sure your disk is fast. Make sure you have enough memory. Make sure you have enough cores, those kinds of things. But there are a few considerations that are specific to virtual servers. So again, I mentioned this earlier, minimal performance penalty, if anything, but you get some flexibility for HADR, portability, scalability by running in virtual. But what we see is that the configuration of the host is key, and the configuration of the virtual server is key. So you want to make sure you don't overcommit resources on a host that's hosting SQL Server. The way SQL Server is designed, it is designed to make use of all the resources on the server, and it will take everything it can get. And if it doesn't actually get what it thinks it should have, then the algorithms that we have for managing resources are not going to work well. If we think we have this much memory and we don't actually get it when we ask for it, then we're not going to be able to make choices effectively inside the engine. You know, we're making all kinds of choices about what should be in memory, what should be read into memory, what should stay in memory, what should I farm out of memory because I want to make room for things that are more important. Those algorithms can't function if I don't actually know how much memory I can really get. So it's very important that if you run SQL Server on a virtualized platform, that the resources you're telling it has, that it actually can get those resources. So try not to overcommit on the host. One thing is power management. So we have those power management settings in Windows and sometimes on the BIOS. You want to make sure you're set for high performance on the host, because otherwise you're going to be losing CPU cycles. And then the last piece, I've been seeing a lot of, oh, sorry, question. Yeah. Yeah. So the question is on the over allocation of resources. We know it's true on the memory side. Is it true on the CPU side?
And I was going to say that our broad recommendation is to have a 1-to-1 ratio of vCPUs to physical CPUs, yes.
Yeah. Because again, we have, just as we have memory managers, we have thread managers too, and we have a scheduler internal to SQL Server. So it's the same thing. We are assuming that we have these processors available to do this work. If we don't actually have them, then you're going to spend longer times actually on the scheduler, and that's going to cause other threads to back up.
And because we do that thread scheduling ourselves, if you have an underlying system that is then sharing that resource with other VMs, for example, then that means that we are not scheduling as we think we are. You'll see added weights in the system, and that can trickle a whole performance issue that it's not easy to troubleshoot.
Yeah, that's what I was going to say. It's really not easy to troubleshoot because it's hard for us to see. It just looks like we're using a lot of CPU. It may not, but it may not be visible from the ESX host side, because the follow-up question was, wouldn't that be something that you'd manage from the ESX side? The problem is the way SQL Server manages scheduling internally, it's not going to show up as like too much CPU coming from SQL Server, because we're going to send out one thread per logical core that we see, and then that's going to go out to the host. I don't know what those other hosts are doing. It may show up as 100% CPU on the host, but it may not. It just has to do with the way the scheduling is then working on Windows on the host.
Because you then have two-level scheduling, and we've seen cases where that simply does not scale well, and it hurts what's the platform on top, which in this case is SQL Server.
Right. So, yeah. Okay, so the question is there any standard for SharePoint to reside on physical servers? I would refer you to a SharePoint resource. I don't see any reason, from my perspective, why a SQL Server that backs a SharePoint should have to be on physical hardware, but they may have some unique requirements that they recommend for. But again.
Because are you referring to documentation you've seen pointing to that? Because I would question that, and there is nothing, as far as I know, in the SharePoint engineering group that I've been talking to lately that points to that. Namely, SharePoint actually runs in Azure, which is supported on VMs. So
yeah.
There may be some specifics to your SharePoint workload that I don't know, and that consultant made that call, but it's not a generic best practice, which is what we're talking about here.
Good answer. You're running SharePoint in virtual?
Yes. And
across, yeah.
I know many customers that.
Yeah, and many that are doing it, yeah, so. Yes?
So your 1-to-1 ratio of vCPUs to CPUs, you've got a large Hyper-V farm. How do you ensure that balance, if you will? If you're trying to present NUMA nodes to multiple VMs at once, how do you control that ratio to make sure they get one?
So let me.
We've not really run into that.
Right. So the question or comment is, how do you balance between NUMA nodes when you have large Hyper-V farms and you need to balance resources? Let's take this offline deeper, but my statement here would be, virtualizing SQL Server is a way to achieve flexibility of moving around to, let's say you need to migrate to newer hardware, leverage better resources. You don't need to be worried about the hassle of reconfiguring the on-top platform, which is SQL Server. It is not the resources themselves should be managed as a physical server. That's the most 10,000 feet view I have of the entire stack.
And remember, we're talking about tier-1 servers. So
yes,
these are your
absolutely.
servers that you really care about.
Absolutely.
There may be other servers that don't have as critical of a workload, and they can go on a server that has 100 VMs on it, and that might be okay. But when we're talking about tier-1 where performance really counts, yeah, we basically want you to treat your VM host almost as if it's dedicated to SQL, right? Okay.
And we can take this offline.
Yeah, we can do much more of that offline too. Okay. All right, but there's one more thing I wanted to say about NUMA. Please do pay attention to your NUMA settings when you have a VM with SQL Server on it, because what we have seen lately is a lot of these weird things where we have unbalanced NUMA nodes, where one NUMA node has like 10 cores in it and then another one has like 2 cores in it. And that can cause issues with SQL Server's scheduling mechanism and memory management. So we want to make sure that, first of all, that you do have some level of NUMA inside the guest OS, because SQL Server partitions memory objects and manages scheduling and all kinds of stuff based on the NUMA node. So you will get the best performance if you mimic the hardware NUMA inside the guest VM. So please do pay attention to those NUMA settings. Make sure your NUMA nodes are balanced and you're not coming up with kinds of wonky configurations. And you can usually see that just by looking in the error log in the startup messages. You'll see the cores and the nodes listed out in the startup messages, and you can see whether they're balanced or not. So do take care to configure NUMA. Okay. All right, IaaS. So again, know your workload. But the other thing is tune before you go, if you can. So remember, once you get to IaaS, you're paying for these resources monthly as you're consuming them. So the best thing to do is streamline that application if you can and pare it down, so that, because you don't really want to overbuy. The whole point of IaaS is to buy what you need and then to scale it as you need to scale it. So get that thing tuned before you move it up into IaaS, and you'll have a longer ramp for your scalability there. Sizing recommendations, and these change all the time. Please do not take this slide as Bible, like even a month from now, maybe even next week, I don't know, So make sure you look at the current recommendations for SQL Server. We have all kinds of documentation on setting up SQL Server on IaaS, but as of the day I wrote this slide, the recommendation was DS3 V2 or higher, DS2 V2 or higher for standard edition SQL. Your biggest challenge in IaaS is generally going to be I/O. And I'm speaking of Azure IaaS here, by the way. What we've seen is people, a lot of times, when you're buying storage for on-prem, you're really not thinking about throughput requirements. Again, you're mostly thinking of sizing requirements. And a lot of times when you go to Azure, you're looking at size. Okay, how much disk do I need to fit my database files? You're not thinking about IOPS. You have to be thinking about IOPS when you go to Azure IaaS, because you are paying for IOPS. You're not really paying, I mean, yes, you're paying for size capacity, but you're going to run out of throughput way before you run out of size in most cases. So use premium storage, make sure you measure the IOPS before you go to Azure, and make sure you have enough disks to give you that level of throughput that's required. You will most likely have to stripe across multiple disks in Azure to get your throughput requirements for a tier-1 server. So make sure you understand that before you go, and then get enough disks to support that throughput, and then you need to stripe across them. Now, SQL Server does allow you to have a single file group, and you can have multiple files, and as long as they're equally sized, we'll round robin across them. But what we found in Azure IaaS is it's probably best to leverage storage spaces to create a virtual partition for you across all those disks. That seems to provide better throughput than just relying on SQL Server's round robin algorithm to do it. Okay, so recommendation, premium storage. Measure your IOPS, make sure that you're buying enough disks to cover your throughput. And then also, all those I/O optimizations that you might not have paid attention to on-prem because you had unlimited hardware, now you want to really pay attention to them. Look at things like page compression because that minimizes I/O as well as size, and things like instant file initialization, anything you can do to optimize that storage. There are a lot more recommendations for things like cache settings and all that kind of stuff in this documentation that I linked to on the slide here. So when you download the slide deck, there's also a few other links scattered throughout that will help you. So that'll give you the latest documentation. And always remember, everything in Azure is changing really fast. So when you get ready to do that, don't just reference my deck. Go ahead and go up to the links and look for the latest recommendations. Okay. All right. So any questions before we move to OS?
Okay.
Cool. All right. So apply the latest version of the OS if possible. Windows is innovating just as fast as SQL Server is. So latest version of the OS is going to give you best performance and lots of awesome cool features. So try to be on the latest and greatest, and that includes patching. Keep up to date with those OS updates just as much as you keep up to date with SQL Server. And you're going to see the same bullet on the SQL Server side. Keep up to date with cumulative updates because we're always releasing fixes, and we are on a very rapid development cycle now. It's not like the old days where you can wait a year for a new service pack. These are tested. They're going up to Azure first. It's good code. Run it. So keep it updated. Keep it patched for security and for performance reasons. Power plan must be set to high performance. So again, if you're running on physical hardware or the host for virtual hardware, make sure you're on high performance. It's not that we don't like the environment, it's that we want our SQL servers to be fast. Paging file. I said, do we really need to talk about this? And Pedro's like,
yes.
Yeah, I get questions all the time about paging file. I'm like, really? Here's the deal. If your SQL server is paging out memory, add more memory, okay? RAM is cheap. Okay, if you're paging out to Windows, your tier 1 SQL Server cannot keep up, okay? If it's supposed to be in memory, it needs to be fast, it needs to be in memory, okay? So don't worry about your page file, just add more memory.
There are other uses.
Yes, okay, that was the first thing I'm gonna say. There's more bullets here. You do still need a paging file, which is why it's on the slide, besides the fact that we get questions. There are some things that do still go in the paging file, and one of the key things is if you need to get a kernel memory dump. So if something's going on the server and you need us to troubleshoot it, we need to get a memory dump to get that. And when you get a kernel memory dump, it goes into the paging file. So you want to make sure that your paging file is big enough for the kernel memory dump. I can't see the notes. What was the number? 16?
So 8 used to be good up until Windows Server 2008 because usually that was the virtual address space for those servers. We now can address up to 16 terabytes, 24 terabytes, I think, of
virtual address space?
Even larger than that, I think. The point is, per our customer service support, we haven't seen much more than 16 gigs being required for a full kernel dump in modern systems. So 16 can be your, there are other recommendations on how to get the sweet spot for your specific system in the notes, but if you're looking for a magic number, 16 is good enough.
Yep.
No,
Not anymore.
So starting with Windows Server 2008, it can be anywhere. You don't need it to be on the boot device.
The question was, does it need to be on the boot device? It used to be in the older versions of Windows, you had to have that paging file on the boot device or the C drive. That's no longer the requirement. Okay. So you can have a small page file on the C drive, and you can put the 16 gigs somewhere else. Yep. That's true, but the thing is, you can't have SQL Server paging out. So if you're seeing this error message, a significant part of SQL Server process has been paged out, your SQL Server is slow. It's going to be slow. So I would say move up to the next size if you can. And as far as the paging file recommendations, they're going to be the same because it's based on kernel memory dump. So they really are the same. The point is, the reason why you used to have to pay so much attention to sizing your page file before is we were guaranteed to not have enough RAM to run the workload, so we would have to be swapping out. And you just can't be swapping out on a tier 1 SQL server. I can't stress that enough. It just kills your performance. Okay. Yeah. Oh, true, yeah. Yeah, we're going to talk about that, yep. Okay, so what the comment just was is maybe another thing you could do is actually solve the problem that's causing you to run out of memory. That's always a good answer, right? Why don't you examine the application? Why don't you see what else is running on the box? Do you have McAfee chewing up RAM? Do you have some kind of monitoring tool chewing up RAM? Is there some kind of third-party application that somebody threw on your SQL Server one day that happens to be running in the background? Just look at what else is chewing up RAM and get rid of that. So that's definitely one way to respond to that reactively. But the other thing he mentioned was lock pages in memory, and we're going to talk about that as well.
Disclaimer, we don't have a beef with McAfee.
Oh, sorry, yes, I'm sorry, I shouldn't say McAfee. It's just one of the most common antivirus things that are running all the time, right? So, yes, no beef. I could say the same for Norton or Windows Defender, right?
Let's just move on from the topic.
Yes, okay.
Thank you.
All right, NTFS configuration, most of this should be done for you in the newer versions of the operating system when you create a partition. It should be created automatically as being aligned, which is the most important. We do still recommend 64K block sizes for SQL Server. So if you're building a partition from scratch, 64K block size, make sure the I/O is aligned. And make sure you turn off any kind of encryption or compression that happens at the NTFS layer. That's just going to slow us down. If you need to encrypt, do that using transparent data encryption. If you need to compress, use the built-in data compression and backup compression. Okay, just avoid it on the NTFS level. Okay. All right. SQL Server. That's what we're all here for. Yay! Okay, first thing that we've seen, I cannot tell you how many customers that have been bitten by this. And I personally have been bitten by it in our labs when I'm building SQL servers to test in a lab. And all of a sudden, what I notice is, I'm just going to click through. Here we go. What I notice is, wait a minute, why am I only using 20 or 40 cores? I've got like 128 cores on here. What the heck is going on? What's going on is I would install the wrong version of SQL Server. We have two different licensing models in SQL Server since 2012, core-based licensing and cal-based licensing. And each one of these licensing models has a different set of binaries. But they are very conveniently named exactly the same once you get them on the disk. And it's the same size. Everything looks the same. So if you've already downloaded the media for SQL Server and it's sitting on a share somewhere, you may not know which version of licensing to get. So if you actually have core-based licensing, which is what we find most of our customers have.
And if you've purchased in the last few years, that's what you get.
Yeah, right. If you've purchased recently in the last few years, you've gotten core-based licensing. We don't even really sell cal-based licensing anymore. It's just there for backward compatibility.
Or if you've
upgraded your EA,
that's long time running, then you may have still cal.
You may still have cal licensing, but most of you probably have core licensing. So what happens is you need to download the media that says Enterprise Core edition of SQL Server. And a lot of times I would go up to MSDN and I'd be like, oh, Core, they must mean Windows Core. I don't want that. I want the other one. No, they mean core-based licensing. The other one is cal-based licensing. So what happens when you install the cal-based licensing binaries on your server is we limit the number of cores you can use to 20 physical or 40 logical processors. So you'll see a message similar to what you see on the slide saying I detected 24 total processors, but I'm only using 20 based on SQL Server licensing. So look for that message. Make sure you're actually getting all the cores that you paid for. Okay? So when you go to download media, download Enterprise Core, as long as you have the core-based licensing, and look for this error message on your server.
By the way, if you're already running with cal licensing, you can change to core licensing. Just disclaimer.
Yes.
You don't need to reinstall the entire thing.
No, you do need to run setup, though,
yes,
to do it,
absolutely.
but you don't have to reinstall the whole instance. Okay. Yes, it's in the error log when you
the
boot
question
it.
was, is it in the SQL Server logs?
Right, is it in the log? Yes, it is. This is the actual message. I copied it from an error log. Okay. All right, parallelism. Max DOP, this is one of those age-old questions. What should I set my max DOP to? What does Microsoft recommend? Microsoft recommends that you test your workload because parallelism is dependent on the queries that you are running. Some of your queries will benefit from parallelism, some of them won't. Some of your queries may benefit from lots of threads, and some of them may just want 2 or 4 threads. It's totally dependent on your workload. So the other thing is, If you have OLTP queries running on the same system as you have reporting queries, the reporting queries are going to tend to go parallel. The OLTP queries are not. So you could have these OLAP queries or analytical queries that take up a huge amount of cores, and they kind of squeeze out your OLTP workload. So you might want to prioritize one over the other. Max degree of parallelism is one of the ways you can do that. You can make MaxStop a little bit smaller so that your reporting queries only go parallel across 4 threads versus, the whole system. Okay, so the default is 0, and 0 is rarely the right setting because generally things will just go too parallel. They'll go crazy. You'll have lots and lots of threads per query. It is workload dependent, so our best recommendation is to test your workload under load and come up with a number that's right for you. Very few people do that, especially on a brand new server. So our general recommendation is it should be set to the number of NUMA nodes in a single, the number of cores in a single NUMA node, no higher than 8 to start. And again, if you're running and you start seeing problems, maybe you want to adjust that number, but that's kind of our default recommendation. There are some vendors who will recommend you set it to 1, particularly for OLTP applications. SharePoint's one of them, right? Don't the SharePoint recommend MaxStop 1? Yep. So, pay attention to your vendor as well. My hope is that they will have done the testing and they will know the right setting. But beyond that, it's really just number of cores in a single NUMA node, no more than 8. Okay. Starting with SQL Server 2016, you can actually set this at the database level if you like. So if you've got a SharePoint database on the same server as other databases, which I know everyone says don't ever do that, but if you do that, then you can actually set that at the database level. So you don't have to set the whole server to MaxStop 1 if you don't want to. Okay, what kind of goes hand in hand with MaxStop is cost threshold for parallelism. Now this is one that there's so much guidance out there. What is wrong with Microsoft? Why do they keep leaving us at 5? 5 is not the best number. It should be 50. It should be 250. It should be 25. It should be... Yeah, that's the reason why it's still 5. Because again, it's testing and it's a decision that you're making to balance parallelism with other queries that might run better without it. So I can't tell you the right number for your system. You really have to test. And if you haven't done the testing and you're not sure, I don't see any problem with 5. Okay, the problems with 5 that most people will tell you is that too many queries will go parallel. You'll have all these queries going parallel, and these other queries won't be able to get CPU resources. If you have that kind of workload, then by all means, raise your cost threshold for parallelism. But not everyone has that.
And to what would be the ensuing question usually?
Yeah, and to what would you change it? Yeah, exactly.
So,
without testing, you just won't know.
Just a quick note. We save the cost for parallelism in every single plan that you have in your cache. You can actually, and we have in our Tiger toolbox, which is the last slide for today's session, some snippets that will allow you to go into the system cache to look at the plans and actually see the cost of the plans you have there. Now, that can be used as a good rule of thumb to look at the average cost of your plans, and then if you need to, because you are having performance issues, make a call on this setting. Mm-hmm. Based on tangible data that you're seeing, not a magic number that someone puts up somewhere.
Yeah, agreed. Any questions about that one? Yeah, the question is, if you set it at the database level, will that override what the server level is set at? And the answer is yes. The database level will take precedence.
So for every setting in SQL Server, from what I'm going to say, the lowest level overrides the top level is server, database, query.
Yeah, so if you add a query hint, that will override both the database level setting and the server level setting. Okay.
There's a couple of exceptions, but we make clear what those exceptions are in the documentation.
Okay, cool, memory. Max server memory. There's a very common rule of thumb out there to set your max server memory to 85%. But that's really not appropriate for all workloads. There are some workloads where you should set that much lower, and there are some workloads where you might set it higher. In some cases, if you've got like, I don't know, 24 terabytes of RAM on the system, setting it to 85% doesn't make sense. You're going to waste a lot of RAM, right? So what we want to talk about here is how SQL Server manages memory and how max server memory comes into play. And the reality is there is some memory that SQL Server allocates directly through what we call virtual alloc. It's doing a direct virtual address space allocation with Windows. And when that happens, the memory manager can't influence it. So it can't apply the max server memory restriction. So there is some memory that's allocated above and beyond what you set max server memory to. The main area of that memory is the DLLs for the engine itself and the thread stacks. Okay, so what you set max server memory to kind of depends on the configuration of the server and the workloads you're running. If you're running things like CLR, if you have third-party DLLs that you know are running in the SQL Server process space, all of these things are going to be allocated above and beyond that max server memory. So you have to take that into consideration, and that means you want to set your max server memory a little bit lower to leave space for those other things to allocate memory so that we don't have SQL Server committing too much memory. Okay? The other thing is, if you have anything else running on the box, like SSIS, SSAS, other third-party products, or even another instance of SQL Server, then you need to account for that as well. So you need to account for all the memory that's being used. So what I'm going to pop up here is an equation. You don't need to memorize this. It's in the notes of the slide. You can take the slide. It's also in our documentation as well. We have a link to that in the notes. So if you have an x64 server, I'm assuming everybody's on 64-bit and nobody's still running 32-bit. For 32-bit, the stack size is smaller, that's all I'll say. But for 64-bit, you have a 2 megabyte stack size, which means each thread that gets spun up in SQL Server needs 2 megabytes of memory allocated to it to run. So how many threads do you have? That's based on the number of processors you have. So we just said for 32 logical processors, it's 960 default worker threads. You can change that. That's also a setting in SQL Server. We don't generally recommend you change it. Just let SQL Server figure it out. The equation for number of threads, there's also a link to that in the notes as well. So 2 megabyte stack size plus times 960, which is the default worker threads, plus 256 megabytes, unless you've set the -G parameter on startup. -G allocates, we used to call it mem to leave. That's that extra memory that would be allocated outside of max server memory.
We now call it reserved memory.
Oh, sorry, we now call it reserved memory. So that's 256 unless you've set the -G. Plus, we're giving 4 gigabytes for the OS. So on a 32 gig RAM server with 32 processors, that would equal about 6 gigs of RAM, so you would set your max server memory to 26 gigs. So that's what we recommend for the equation. And sometimes this ends up being 85%. So that's probably where that number came from. But this is the real calculation. So if you want to get specific, that's what we recommend. And as I mentioned, depending on your workload, you may have a greater need for memory here. Okay, so know whether you're going to have CLR or anything like that. Yep. Any rule of thumb on SSIS memory?
Very quickly, so SSIS does not have a mechanism to limit memory as SSAS does. Well, actually, even in SSAS, it's not a limit. It's a tentative ballpark number that can be overcommitted. For SSIS, the best recommendation in a tier-1 server is to move it out of the same box. SSIS is unaware of anything else running, and it's by design, it attempts to, like SQL Server, to grab all the resources in the server that's running on, namely buffer spawning. It's completely automatic, and you can tweak how many buffers are spawned, the rate at which they are spawned, even the size. But as long as there's memory available, it will try to grab it. And SQL Server, being aware of potentially the system, in this case Windows OS, triggering system memory starvation, it will start reducing its own memory footprint to account for anything else running. It's not a good situation overall. So best recommendation is, if you're running packages at large that really support your business processes, move it out to the dedicated SSIS server.
So you have SSIS running on a dedicated server, but you've got an instance of the engine there where you're storing like your package information and stuff like that? Yeah. I would leave it. Yeah, I would just leave it at the default and let it manage it itself.
If you're using if you're just storing your packages in MSDB or something, I mean, it's not minimal. It's minimal.
Yeah. Yep. I would just leave the SQL Server at the default, because the default will let it use. The default is just let it use everything, because it'll negotiate with SSIS. So if you have a dedicated SSIS box, Sorry.
Oh, there's no, so the question is how much RAM would you put on a dedicated SSIS machine? There's no rule of thumb because it really depends on how many packages you're running, what are those packages doing, and therefore in a test environment you have checked how much memory, because we have performance counters for that, how much memory your packages as they are running, maybe several at once or one at a time, have taken it, and that's a calculation coming from there. There's no rule of thumb for that.
And it's really dependent on what the packages are doing. If you have packages that are just orchestrating stored procedure executions, it's not going to use much RAM at all. If you have packages that are loading very large text files and then bulk inserting those into a database and the package is driving the data load, that's going to use a lot more memory. So it's really the same thing as if you ask me, what's my default for a SQL server for how much memory to give it? It would go anywhere from 2 gigs to 24 terabytes, depending on what you're doing, right? So it's kind of the same thing. Know your workload. Okay.
Half an hour.
All right. Cool. So min server memory. So max server memory is kind of protecting everything else on the server to make sure everything else on the server has memory. Min server memory is what's protecting SQL Server from giving away too much of its memory. Because SQL Server is a good citizen. SQL Server is paying attention to what's going on the server. It's watching Windows. It's looking for memory constraints within Windows. It's looking for memory pressure. And when it detects memory pressure, it will adjust its own memory footprint down to accommodate for that. And that's why when we're living on the same server with something like SSIS that doesn't have any of that intelligence built into it, then we're going to get stepped on. Because we're going to be like, oh, OK, you want more memory? Here you go, here you go. And SSIS will be like, grab it all, right? And SQL Server will do that too, provided that there's nothing else going on. As long as there's plenty of memory, SQL Server will grab it all. But as soon as we start seeing evidence of memory pressure, we will start reducing the memory footprint of SQL Server. Okay, so if you have anything that has potential of taking memory away from SQL Server, then you need to set min server memory to protect SQL Server from giving too much memory away. So if you have SQL Server running on a dedicated server, this is not usually that important. If there's nothing else going on, SQL Server has full access to the memory. It's going to take what it can get, and it should be fine. But if you're running other things, again, like SSIS or AS, if you have other instances of SQL Server, you want to protect them from each other by setting their mins appropriately. And the other thing is if you are running in a virtual environment and you have perhaps overcommitted memory, and you have this balloon driver happening from the host that's like simulating memory pressure, that will cause SQL Server to give back its memory, even if it can't really afford to give it back. Even if that's making SQL Server do a whole bunch more disk I/O, if it's got memory pressure, it's going to give that memory back. Okay, so min server memory is your protection from giving too much memory away. So that's what you want to leverage min server memory for. So default is fine for most workloads, but if you're running in a virtual server, if you have other workloads, or if you're running multiple instances of SQL Server, you have to kind of balance that workload across the different instances that are running, and you set the mins appropriately. Okay? Just to dispel a sometimes common myth, SQL Server doesn't automatically grab min server memory at startup unless you have traceflag 834 enabled. So normally, even with lock pages and memory turned on, we don't automatically grab the memory. We grab it as needed. The min is just protection from trimming, okay? Unless you have 834 enabled. Yep? Okay, so the question is, let's say you had SQL Server running on a VM in a VM environment. How would you know that you were being impacted by that balloon driver, that you were having memory taken away? That's a really good question because it's really hard to see. The only customer where I ever was able to successfully detect it myself was a customer where I saw that SQL servers, so the target server memory is going to be based on max server memory and how much memory is available on the system. The target server memory was much less than max server memory was set to. And the total server memory was even less than the target, and they were kind of like bouncing up and down. And what I saw was, it looked like when I looked at the operating system, this is the guest operating system inside the virtual server, it looked like there was plenty of memory available. So we had all this available megabytes, but SQL Server wasn't taking any of it. It was way lower than it should have been. I was like, this doesn't make any sense to me. And then we got the VMware guys involved, and they determined that, yeah, that what was happening is that Windows OS, the guest OS, was not actually getting all the memory that it was entitled to. So it's hard, and that was years and years and years ago, so it may be different now. The counters may be different. I'm sure there's perfmon counters that you could look at. That was the way I figured it out. I don't know if you've ever seen that.
I've seen it once.
Yeah, same kind of thing.
Very weird target
yeah.
versus total server
Very
memory.
weird target versus, so these are target server memory and total server memory are SQL Server Memory Manager counters in perfmon. And then available megabytes is the Windows counters, okay? And that's what we were looking at. We found discrepancies where those didn't make sense. So would we be looking for stolen memory? So stolen memory just means that it's memory that's not being used for buffer cache. So there's nothing really wrong with stolen memory. So it's not really bad. I know stolen sounds bad.
It wouldn't show up in this. It wouldn't be a symptom in this case.
Yeah.
That other question.
No, it wouldn't manifest as stolen
exactly.
memory. It really just manifests as numbers that don't make sense. Target server memory should be equal to max server memory if you've set it, or the amount of memory available minus 3 gigabytes or something like that in the latest version of SQL. If it's lower than that, then something's preventing it from getting that memory. Okay? Anybody?
Nope.
Okay. Large pages. So we mentioned this a little bit. So lock pages in memory, we now recommend this is pretty much a good thing to set on your tier 1 servers. So if you do set lock pages in memory, you want to make sure that you've set max server memory to something in line with the recommendations we just talked about. The problem with lock pages in memory is what this tells SQL Server to do is to allocate memory using a special Windows API that prevents it from being paged out to the paging file. So that's great because Windows memory won't get paged to the paging file, but it also means that if the OS gets in trouble and runs low on memory, it can't page out SQL Server's memory and it could actually cause the server to crash. So you want to make sure that you've left enough memory for the OS if you set lock pages in memory. Not everything gets locked in memory. There are some things that don't get locked in memory, but the majority of SQL Server's memory space, the buffer pool especially, will be locked. And if you want to use large page allocations, you need to do this lock pages in memory. So it's good to avoid paging. It's also good if you want to use large pages. So talking about large pages.
We have 24 minutes.
OK, I got to go fast. Trace flag 834, this turns on large page allocations for the buffer pool. This is generally good for analytical workloads, large queries that query large portions of the buffer pool, because this allows us to do larger memory allocations and fewer of them. So it's a little bit more efficient. We don't have to make as many calls to the memory manager, and we can get large chunks of contiguous memory. And then this allows us to be able to be a little bit more efficient with our memory access. So large memory machines, analytical workloads, unfortunately, it's not supported with column store. And the reason is there are some issues with the way column store allocates memory, and you could overcommit memory, go beyond your max server memory if you turn on 834 with column store indexes. So at this point, we recommend not to do it with column store, but it's appropriate for other workloads. OK, I/O. I talked about this a little bit already. Instant file initialization, so this allows you to, when you grow a data file, we don't have to zero it out. We just grab the space and move. So starting with SQL Server 2016, this is an option in setup. So we do recommend you turn that on. File placement. This has been an age-old argument for as long as I've supported SQL Server. We do still want you to have separation of log files and data files in tempdb. The workloads are different on your log files versus your tempdb files. The requirements are probably different. The I/O patterns are different. So we do recommend that you separate them. Even if you're on a SAN where it's all getting mixed together, we still recommend that you separate them logically. But there's not really a reason to have multiple logical drives and have multiple files spread out across those logical drives, unless you need to do that for, let's say, VMware because you have like multiple VHDs, or for sizing reasons. Usually if you're on a modern SAN, you're going to be spread across the same spindles anyway, so it's not really needed to go that way. So I generally rely on the I/O subsystem and just create one data file and one tlog file unless I'm doing something like partitioning.
There's one question there.
Yeah. If I only had two, would I separate log or tempdb?
Why can't you have 3?
I guess I would say it depends on your workload. If you have OLTP workload and that transaction log is crucial, I would separate out transaction log. If you have heavy reporting queries that are spilling to tempdb all the time, separate out tempdb. Yep. Different SCSI adapters. Oh, okay, yes. So if you have multiple SCSI adapters, especially if you have like direct attached storage, then yeah, you need that for extra throughput, then separate it out that way. If you're going through a SAN with like with an HBA with multiple channels on the HBA, probably don't need to. Yeah. Multiple ones on a SAN. So that's getting into talk to your storage vendor, because I don't know how your SAN works, and they all work differently, and some of them are super complicated. So I would say go to your SAN vendor for that, because they'll know better, and hopefully they know SQL Server workload patterns, and they'll be able to give you more advice. Because usually in the SAN, there's like a massive cache in the front, so you're not hitting the disks directly, at least for writes. You'll be hitting them for reads. So it's really going to depend on what they recommend on your workload, I would say.
With multiple LUNs, you want to make sure, like Pam said, you're meeting your IOPS requirement, which means that you need to have the appropriate number of spindles underlying that LUN. So again, referring to your storage vendor for that.
Right, which you may be able to put all those spindles under one LUN, and then you spread across all the spindles versus having half the spindles in two LUNs. It might not actually be better that way. Your vendor would know. Ah, that's a very good question. I thought multiple data files in tempdb was a good practice. Yes, it is, but not for disk I/O reasons. Yeah. And we are going to talk about that. I hope that should be like the next slide, right? Something like that.
It's the next.
We'll talk about that, so hold on that. Yeah.
We have that in the next slide.
Yeah, we'll talk about tempdb in a minute. I have a whole slide for tempdb. Yep.
No, we do not.
No. Do you have a comment about thin versus thick?
I have more than a comment. Let's take that offline.
Let's take that offline, yeah. Okay. Anything else? We're running short on time, and Pedro talks a lot, so.
Really, Pam?
You know I had to get the dig in there. You know I did, right? This is why I'm talking first. Okay, no. Oh, it's revenge for the, no, sorry.
Let's move on. Let's move on.
Okay, we're wasting time. All right, tempdb. Fast storage, okay? Tempdb is, I'm not going to say what Brent Ozar calls it, but it is important because everything in your server uses tempdb. If you have a sort that spills to disk, it goes to tempdb. If you create a temp table, it goes to tempdb. If you create a table variable, it goes to tempdb. Even though you think that's in memory, it's not. It may spill to tempdb. So there's so much going in there. When you rebuild your indexes, you might have sort and tempdb turned on. If you have row versioning-based isolation levels, that's going to tempdb. There's a lot in there. It's probably the busiest database on your server. So it needs to be fast. Flash, SSD, it doesn't have to be redundant. So don't put like fancy RAID 10 on it. Just avoid RAID 5 and 6 particularly. But I mean, it can be cheap. It just needs to be fast, okay? Because tempdb gets destroyed and recreated every time you restart SQL Server. Everything in there gets thrown away. So there's no need for it to be redundant or fancy. It just needs to be there and fast. Okay, so multiple data files. So why do we tell you to have multiple data files if I told you not to do that in your user databases? The reason is, and I just wrote a blog about this a couple months ago, so if you search for my name and tempdb or something like that, it'll probably pop up. Or if you go to the Tiger blog, we have links later on, you'll see this post. The reason for the multiple data files is for in-memory contention that we see on object allocation pages. So whenever we allocate space for an object in tempdb, we need to use these pages in order to find space to allocate, and they're held in memory. And when you have multiple threads all trying to allocate space in the same tempdb file at the same time, there's contention on these pages. So the reason for the multiple files, and they have to be equally sized in the same file group, is so that we get a round-robin algorithm instead across all the files. And then we have multiple allocation pages in memory, and then each subsequent thread should hopefully be hitting a different set of pages. Okay, that's the reason for that optimization. It's all in-memory contention, has nothing to do with I/O. So they can all be on the same drive. You can put them on separate drives if you want, especially if you have like one SSD for each file or whatever you need to do. That's fine, but it's not about I/O. It's about an in-memory contention problem. So we recommend 1 data file per logical processor, up to 8 data files. But this is your mileage may vary. It really depends on your workload. We've had some customers that have to add like 48 tempdb files. We've got some customers that can get away with 2 or 4. It really depends on your workload. Okay, so you're going to look for some contention. I'll let you look at the blog article to read more about that. And remember, they need to be equally sized. Also, if you add new files to tempdb, you need to restart your SQL Server instance. Otherwise, SQL Server is going to now start putting everything into those new files you added because they'll be empty, and they won't be as full as the original files that were there, okay? So even though it's an online operation, you don't really have to restart, you want to make sure that we rebalance across all the files, okay? And also, when you add them in multiples of 4. I don't know exactly why, but it optimizes the round-robin algorithm. So if you're increasing files, go by multiples of 4. Which part of default?
No,
Oh, okay, so it always round robin. The trace flags that used to be involved here are 1117 and 1118, which I have later. 1117 and 1118. 1117 triggered, anytime an autogrow triggered on the database, it would trigger all the files to autogrow at the same time. So that would maintain the round robin algorithm through autogrows. The best practice is to avoid autogrow, then to just presize it though. Trace flag 1118 turns off mixed page allocations, which is one of the contention points. So again, you can read more about that in my blog. Those 2 trace flags are the default starting in SQL 2016.
And in SQL 2016, it's more to the point of tempdb versus other databases. Those trace flags, when you enable them in any version of SQL Server before 2016, they act on all databases,
right.
not just tempdb.
Sorry, not just
so you
tempdb,
need to be aware
all
of that.
databases. Yep, now it's just tempdb. Okay, upgrade to the latest cumulative update. We've been making many fixes and changes to tempdb around metadata contention, not just this object allocation contention, but other contention points that we've seen. So make sure you're on the latest cumulative update, and when 2019 comes out, hopefully we'll have even more improvements there for you. Avoid explicitly dropping temp tables in code. This is sometimes recommended. I don't know why. It will go, when the stored procedure goes away, the temp table goes away. If you explicitly drop it, we can't effectively cache it, and it causes additional metadata contention because we can't leverage the cache. So please don't explicitly drop your temp tables. All right, I'm going fast, Pedro, I'm sorry. NUMA. We already talked about NUMA. I won't spend too much time here. Just to say, whether in virtual or physical environment or IaaS, NUMA is still important because SQL Server partitions memory objects and does thread scheduling based on NUMA nodes. So we have soft NUMA enabled by default in 2016 and later, and 2014 SP2 with trace flag 8079. So this allows us to better partition memory objects based on if you have NUMA nodes that have greater than 8 cores. Okay, trace flags, last thing, and then I'll switch to Pedro. Sorry. I didn't realize this would take so long. There's so much good stuff. So there are still some trace flags that we do want you to enable by default, unfortunately. We are moving away from trace flags as best we can. We're trying to make these all settings. We don't want you to have to go searching for all kinds of undocumented trace flags. Anything that is on this slide is documented. You can find it if you go to aka.ms/WAC trace flags. This is all documented. We have articles that talk about high-performance tier-1 servers. All of these are documented there. So we're doing our best to document them. And moving forward, future versions of SQL Server will need fewer and fewer trace flags. So right now in 2016 and 2017, there's a couple outstanding issues that you still need trace flags for. One is 174 for some spin lock contention. 4199, I'll let you talk about that. 3468 disables indirect checkpoints on tempdb. Go read all these KB articles, because these are all customer issues that we've had on covering. So I don't want to spend too much time here, but read the KB articles, and they'll tell you a little bit about why I'm telling you about these trace flags. 7471 allows you to update statistics in parallel, so that if you have very large databases, you can have multiple stats jobs. Faster checkdb, lightweight profiling you're going to talk about. 117, 1118 we already talked about. I'll let you guys read these. So the one thing I want to point out, though, is 8075, that last one, vast fragmentation. If you're not in 2016 yet, if you're on 2012 or 2014, please turn that one on, because I've seen all kinds of weird issues around that. So 8075. I'll let you read through the rest.
So bottom line on this slide is these are best practice recommendations. You should turn these on in these versions to get the best out of a tier-1 SQL Server deployment. Yeah.
And with that, I will hand you, oh, sorry, one more question, then I'll hand it over to Pedro. So when we can, we do that. The problem is they make behavior changes, and sometimes they can cause a negative impact as much as they can cause a positive. So there are some of these where we don't want to like pull the rug out from someone and a behavior changes that they've been relying on. So we try really hard not to do a behavior change in a cumulative update. A lot of times what we're doing is next version of SQL, that becomes the default. And that's what you see, like, oh, I switched, but you can see 2016 and 2017, a lot of those trace flags in 2012 and 2014, they're all the default behavior now. So version to version, we're trying to do that. We can't really do it in a CU. So
and to get to the last section, in the first slide that you saw with the several topics we're going to discuss, application sits on top of it all. So a few quick notes on partitioning. This triggers a lot of questions on and off. Partitioning is a strategy, and it's a strategy to lay out your data that will later affect how your queries execute and the overall performance of the server. So it's not just about storing and properly storing data, it's about being able to unleash the power of the queries that run on top. So a perfect fit is for VLDBs, namely on sliding window scenarios, that you have data that naturally ages out and you want to keep focused always on the latest set of data. That triggers the ability to do fast archiving, meaning I can switch out, switch in partitions that have aged data very quickly. That's a metadata operation, which means that you can quickly do these to bring in data that's required, that has aged out, and then put it back into your data warehouse, for example, or online data warehouse. It also allows piecemeal restores and therefore file group level backup and restore, which means that, for example, for faster recovery time objective, you can, in a database that has a lot of read-only data, that you have backed up those read-only file groups, you can quickly put that database back online in a new server just by restoring the primary file group, and the database can become online, and then you keep on restoring already with the database online your other file groups, and you have a much faster time to recovery there. So the point here is how to find or how to set up the proper partitioning for your database, for your specific workload. It's all about understanding what the business needs from that database, and that translates into the queries, and examining your schema to understand if you have already columns that are eligible to make sure that you partition over that. For example, if you have a sales table and you have sales date, that may be a good natural key for you to set up your partitioning key over that, rather than creating a new surrogate column. If you have an incremental ID and you want to partition by X, like every 10,000 records or every 100,000 records, you partition to a new partition, so to speak. So you can use that as a natural key for your partitioning algorithm. Now there's a point about partition aligned indexes. You have partitioned your tables. You don't necessarily have to partition your underlying indexes. Now, there's a couple of reasons why you should do that. The first, I've already mentioned, the ability to do fast archiving, switch in, switch out partitions. That's only possible when all your on-top indexes on that table are partition aligned. That allows you to do that. It's also, you need to be aware of your queries. So again, understanding the workload that runs on top of that table to understand when to use partition rather than not using it. For example, to look at your most used where clauses, the join arguments in your queries, to understand where you need to create indexes. And if you have, for example, something that, or a column that is eligible for a partitioning key that is recurrently in your indexes, like the date of a sale, a specific ID range, then use those as your partitioning key, and therefore you leverage both the power of partitioning and the query optimizer ability to skip partitions that don't fit your predicate. Now, be aware of the converse issue, which is if you have a lot of queries using top keyword or min and max, we kind of have to scan through all the partitions. We can't skip partitions that don't meet your where clauses and whatnot necessarily. So be aware of that. That we may have to scan all the partitions even when you're using partition tables. So I'm kind of going quickly over this because we're running out of time here. Now, collations. Why are you bringing up collations when you're talking about best practices for SQL Server? What does that have to do with performance, if any? Well, there's a couple of things I want to talk about here. One is classic, let's say, workload inadequacy. So you should really, like when you're deploying SharePoint or some other vendor application, usually they do have recommendations on what is the default collation you should set for the server. Why is that? Well, remember that tempdb gets recreated every time we start up SQL Server. And that gets recreated mimicking the model database, which has the same collation as your system database, as your entire system, I mean. So that means that if you have a user database with a different collation that may or may not be compatible with the collation that's running tempdb, and you're running, let's say, a query that needs to spill to tempdb and run its sort operations there. If you don't take care of accounting for that even in your query, for example, using the collate keyword, you may actually run into errors in SQL Server saying that, oh, we can't run this comparison because you are using incompatible collations, and your query just blows up. So it's kind of a big deal when you're setting up SQL Server to mind what am I going to install there? What databases? Are those vendor databases? If they are, does the vendor recommend a specific collation for the database, and therefore I should use that for the server? If it's a consolidated server, then try to see what are your requirements and choose a collation that may be more encompassing, and then make sure the queries are accounting for that potential difference in collation so they don't bomb up when you try to use tempdb, for example. Now, in SQL Server 2019, we're actually enabling a new set of collations, and that is to support, finally, UTF-8 encoding. So that's been a long time request in SQL Server to support UTF-8 encoding. We're introducing that. The reason I'm bringing up this here is if you have databases that use char and varchar data types, and, by the way, you mostly store ASCII, so Latin, Roman characters. That means that just by leveraging these new collations in SQL Server and storing those data types in UTF-8, you effectively get a 50% reduction in your storage size. Just an example here, if you, I did click, yes. For example, if I'm using an nchar, 10, because I need to support Unicode collation. If I turn on this UTF-8 collations, then I turn that data type nchar10 into char10, that translates into nearly 50% reduction. That's because we take 22 bytes to store a full nchar10, and we only take 12 bytes to store a full char10. So, and that's just a mere example. The point here being you can significantly reduce your storage footprint by using these new collations and Unicode-based encoding. And on top of that, you'll do less I/O running your queries. So you see where I'm going with this. Database maintenance. Now, that's also important. You need to make sure that, like Pam mentioned at the beginning, just because you have a very good hardware running SQL Server on top of that doesn't mean that that overcomes every issue going forward. You need to maintain your system. So therefore, maintaining and grooming your indexes to make sure that, depending on the workload, they don't pose a significant overhead. For example, if your indexes are used mostly for scans, then they are most vulnerable to high fragmentation, as opposed to workloads that do mostly seeks. And in that case, you can actually kind of support higher fragmentation without too much overhead. Statistics. Well, statistics are the building blocks for the query optimizer. So the query optimizer can do as good of a job as your statistics kind of lay out the data distribution in underlying tables. That means that you should keep them as updated as possible. If you update your tables and you insert and delete data, the statistics on top of those tables need to accurately portray the data distribution. So therefore, make sure you are updating statistics. Even more important if you are not leveraging auto-update statistics. Integrity checking. Well, no database can be online and up and running if it starts to get issues with data integrity. So therefore, we recommend to run dbcc checkdb regularly, and your mileage may vary. The point is, not running it at all means that you may have corruption creeping in your database, and you don't even know about it. And we have extensive notes on the slides that go deeper into this. So I'm sorry about being kind of running through this. We have a couple minutes.
Blame me.
Query optimizer and cardinality estimation. Well, this would be a session on its own. I actually have delivered sessions just on this. But let's skim through what's most important I wanted you to keep in mind. Every database, every single version of SQL Server introduces new changes to the query optimizer. Now, what we have started doing, especially since SQL Server 2016, is that every new change, which may impact your workload, hopefully for the better, but sometimes it's actually not the case, we introduce under the latest database compatibility level. That means that when you upgrade SQL Server bits to the latest version, you are okay keeping the source database compatibility level, because that means that you are also, from the query optimizer perspective, you are using whatever rules and optimizations existed in the source version you came from. That is your best bet in the first moment to make sure that you are not maybe regressing your workload on account of that. The point is, plan to certify on the newer compat level soon after you upgrade. Now, there's also the point of optimizer fixes. As SQL Server progresses through its life cycle, we release cumulative updates. Up until 2016, we also released service packs. Those are gone, by the way, starting with SQL Server 2017. My point is, we have the requirement to sometimes release fixes for the query optimizer. And that usually stems from working with customers. Now, even apart from the database compatibility level, we have this trace flag 4199 that enables all the optimizer hotfixes. So just because you install a cumulative update that has optimizer hotfixes there, doesn't mean those will get enabled. You need 4199 for that. Now, what you also need to be aware of is, if you upgrade DB compat level to the latest, that also has an impact on what this trace flag does. Meaning, every query optimizer fix that was released up to the SQL Server version that matches the latest compat level, let's get tangible here. On SQL Server 2017, latest DB compat is 140. That means that if you have a database in DB compat 140, you don't need necessarily trace flag 4199 to leverage optimizer hotfixes that came before SQL 17 was released. However, if we have released optimizer hotfixes post 2017, then you need 4199 to enable them. In the trace flag page that Pam mentioned, there's a kind of a small matrix. You can see what where these actually kind of interact with the database setting and the DB compat level. We actually have a session later today where I'll be covering much more extensively this whole notion of DB compat level and what are the intrinsic issues and functionality behind that. Now, as we introduce new fixes to the optimizer, we also introduce in each new version a new cardinality estimation version. Meaning that the bottom line is, there's no more old C versus new C, in case you've heard this at any point in time. We've introduced a new version of the cardinality estimation model back in SQL 2014. At that point, you had an old C and a new C. Those were side-by-side implementations. But starting from there, we have actually been able to, we have introduced new changes to the cardinality estimation model, which means that new C actually becomes C120 with SQL 2014, C130, 140, and so on and so forth. So there's no, I wanted to keep away from the old C and new C thing. We have some more information here. We're now over time, so I guess I'm going to wrap up.
But we are going to cover a lot of the stuff that we were going to cover in this last section here with the query store, query tuning advisor, things like that.
In that session, though.
These will be in Pedro's theater session,
and also
which is at 11:55 a.m. in the expo hall. So he'll be covering a lot of the same demos we were going to do here. And also we have a session later today on modernizing your SQL Server, and we have some of these demos that will be there as well. So we'll talk more about the query store and the query tuning advisor there. So if you want to come to those sessions, we can follow up. So I apologize, it's my fault.
That's fine. Just as a wrap up, what I mentioned, the Tiger Toolbox, it's a GitHub repo we have. There's a bunch of scripts and snippets of code there you can leverage for all your best practices needs. We have a script there that actually checks for everything we've discussed today and more. If you kind of want to do a quick health check on your SQL Server, you can leverage that. Maintaining your indexes, statistics, all of it is there. Thank you very much for being here this morning.
Thanks, everyone.